One could use gravity as an opposite and equal reaction, but that would undermine the observation that the external ends of the universe are seen to be moving away in an accelerated fashion, illustrated in the Hubble constant. The unification of a divergent force could possibly share a similar wave pattern and set of vibrational frequencies with the other forces of nature that needs to be present if there is to be a unification of the forces. The aggregate force could affect the rotation of not only Earth, but other celestial and planetary objects. Another term or phrase denoted by myself is describing the state of nature causing two constants to work in relationship of each other, which I will call a binary constant. The binary constant form keeps the integrity of the total constant, but allows for vibrational wave adjustments in an elliptical path, a sharing of ratio values of lambda and g with each other, but retaining its total constant value. An inward force ratio would cause items to weigh less when they are on the side of the Earth closest to the Sun, because the Sun's mass possibly shifts the ratio of the binary constant, lambda g, towards the Sun. However, observing the strange occurrence of data models of ocean tides, there is a low and high tide that is counterintuitive and unexplained. If you investigate the timing of occurrence of both high and low tides when the Sun and the Moon are at their aphelion, there still can be a high tide. The separation of the tides by 12 hours twice a day instead of the intuitive 24 hours when the Sun or Moon, depending on trajectory, is closest to the tide in question is an unexplained phenomenon. Say the Moon stays near the Sun on its 28-day rotation around the world. I've collected some data points with the Moon near the Sun showing an irrational tidal landscape that has been reflected upon by scientists. I still cannot derive a consistent and intellectual explanation of the data I've collected. There seems to be an equal and opposite reaction of the tides that is completely unexplained. The closest deduction that I can surmise is a conceptual force akin to the cosmological constant, or Newton's third law, bulging the water out on the opposite side of the location of the Sun and Moon, explaining the 12-hour cycle. During the course of the ellipse of the trajectory of the Earth in its rotational orbit, the gravity side of the binary constant should intuitively behave as though it's more of an attractive force in the northern hemisphere's summer with this large mass of land attracting the Sun. In fact, it is exactly the opposite. In July, at the aphelion, the land-rich northern half of our planet is tilted toward the Sun. On January 4th, 2003, our Earth made its closest approach to the Sun for the year. At the greatest separation, the two are about 152.6 million kilometers apart. The average is 149.6 million kilometers apart, which will occur this year on July 4th, according to NASA. When they are at the farthest apart, the lambda part of the binary constant is at its greatest. The two ratios change with the apparent movement of the two planetary bodies. The Earth has, at its most extraneous point, has a tilt of 23.5 degrees, dictating the seasons yearly, oscillating back and forth. It is 27 miles longer around the equator than the poles, which is almost uniformly circular. The Earth is also relatively top-heavy in its measurements, which change its binary constant measurement and highly complex movements with the given factors of distance, mass, and force on each separate tensor vector that covers the Earth and pushes back on the Sun. This effect on planetary bodies, binary constant ratio, should be observable in the known universe. If you're on the side farthest from the Sun, you would be experiencing more attraction of the lambda side or cosmological side of the ratio of the binary constant, explaining the counterintuitive tides that are observable. In the lambda force and gravitational force, when intertwined, the gravity side must be stronger than the lambda force relative to us on Earth, keeping us firmly affixed to the ground even on the farthest side of the Earth. farthest from the gravitational pull of the sun and the moon. In Einstein's general theory of relativity, he hypothesized gravity waves as the reason why space bends and curves, causing what we see as gravity. Looking over long distances in which you can see the curvature of the Earth in the horizon, the idea of gravitational waves holding items to the Earth seems like an intelligent one. It offers some explanation on the changes of gravity dependent on position and allows the malleability of the force as a whole dependent on mass. Another example of the relationship of cosmological constant and gravity is visible in collapsing stars. There is a critical mass of a star that will reverse its lambda g field as it reverses near the planet. It is a term that explains the innate switch from a convergent property to a divergent property. That critical mass is unknown, but when there is a divergent property observed, it could have been similar to what caused a large-scale mass creation and ejection of solar bodies, in which scientists identify as galaxies moving away by their redshift. It possibly could have been the source of our early universe. To observe a supermassive black hole, we could be observing a body that could soon turn into a white dwarf when a critical mass is reached. The critical mass reversals and jettisons are most likely responsible for what we see in the distant quasars. It is a challenge to find an experiment to prove the existence of a critical mass when lambda g being seen to be flipped as g lambda. The attainment of critical mass causing the outward expansion of the universe is a paradox that is seldom seen through observation. This is challenging because a large switch of g to lambda causing the ejections and contractions are incredibly rare in the universe. We just see the remnants of these explosions in space. The aggregate force of gravity lambda could possibly be measured easier near bodies like the moon as it orbits with our Earth. The moon and Earth would delineate different values for the binary constant at different periods of orbit. The two forces, gravity and cosmological constant, are in their very nature an antithesis of each other, similar to other fundamental forces like electricity and magnetism.